So let's talk about the evolution of forces. And I will jokingly refer to this as A Brief History of Time, the title of a very, very famous book by Mr. Stephen Hawking. And the irony in this brief history of time is that it is not brief at all. It is 13.8 billion years, and the time began in the very beginning, the Big Bang, ending until now. And so what this diagram depicts is the evolution of the universe from its very beginnings as a point, a size where all the mass and energy in the universe was located at one point in an instant in time 13.8 billion years ago. The universe expanding and going through several different eras leading up until now. And so what this represents, if you view this as a slice through this cone that you see here, the entire universe is depicted as residing on this surface. Now, I want to start from the beginning because there was this Big Bang, and the first major event that every person should really know is that there's this event that happened about 380,000 years after the Big Bang. And what happened then is we had our first atoms. Before that, they were nuclei. And at 380,000 years after the Big Bang, those nuclei captured electrons, and we had our first atoms in the universe. And then at about 300 million years, we get our first stars appear. Now, that's a long period of time for there just to be atoms and so forth. And if we write out those numbers, 380,000 versus 300 million, well, we can see the stark contrast. This has 6 digits in it. This has 9. So this is 1,000 times longer than the first event that happens. We get our first stars about 300 million years after the Big Bang. And after about 1 billion years, or about 3 times longer than that, than it took for the stars to form, we have our first galaxies. And then today, we are at about 14 billion years. So the major events are first atoms, first stars, first galaxies, and today. And every self-respecting science student should know and kind of have that timeline in their mind. Now, what's interesting is that if you look in this last period between the first galaxy and today, well, there's 13 billion year difference in period of time, but our sun formed in the last third of that. So about 4.5 billion years ago. So if you divided this period that there are galaxies into thirds, the first third, the second third, and the last third, ours, didn't come into existence until the last third. So out of the 14 billion years, our own galaxy didn't appear until about 9.5 billion years after the Big Bang. So if we were to draw a nice extra ring here, this would situate and you can see there our solar system forming about right then and there. That also means that prior to that, our sun did not exist. Our sun and our entire solar system came into being 9.5 billion years after the Big Bang, or 4.5 billion years ago. Before that, our sun didn't exist. So those are our 3 main areas. And if we were to put this to scale, so we have 14 billion years, and we said 9.5 billion years is this juncture. So that's where our solar system came into being. And at 1 billion years is the first galaxy. And at 300 million years, I will draw a fine line, because that would be 1/3 of a billion years. I'll draw a fine line there, taking us to that. And we said that it is that first 380,000 years, it's 1,000 times longer. So if we draw that to scale, it would be indistinguishable from that 0. So in terms of this representing the history, this timeline representing the history of the universe, we can see this is when our solar system existed, the age of galaxies, the age of stars, and the age of atoms all existed before that. But the vast majority of our time We have had galaxies, but ours only came into existence a very short time ago. So our solar system, galaxies, stars, and no stars. And so some of you may know that the Big Bang Theory is what we now know to be how our universe came to form. And every line of evidence, no matter how we look at it, suggests that the universe formed in a singularity. Singularity meaning the entire universe existed at a point, and that point then expanded. And as it expanded and cooled, we formed matter, and the universe is continuing to expand. A singularity is a location in space-time where gravitational field is infinite. And that gravitational field was infinite at the very beginning of the universe. And for those of you not familiar with what a galaxy is, which could be the case, a galaxy is a collection of anywhere from 100 billion to 1 trillion stars clustered around a central super or ultramassive black hole. And there's approximately 1 trillion galaxies in the universe. So each one of these pictures here, each one of these things represents a galaxy. And so we have anywhere from 100 billion, that's 100,000, 100 million, 100 billion, to 1 trillion, or 10 to the 12th stars inside this. So our Milky Way galaxy could be depicted by one of those as 1 trillion stars, and our star is just one of those. But there are 1 trillion galaxies. So 10 to the 12th times 10 to the 12th is 10 to the 24th stars in the universe. So that sort of situates things. And in our next slide, we'll learn more about how that relates to forces. In our next episode, we'll talk about how that relates to forces.